The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I'll respond as soon as I can. All right, so today we're going to move on to objective 2C.1. And the way I want to start is to go back to something that we looked at a few days ago. And that was when we were dealing with converting a percent into a regular number and converting a regular number into a percent. We said that 1 equals 100%. Therefore, from that equation, we could create the following, both of which are equal to the number 1. And these are called unit conversion factors. It's a unit in that it's equal to 1. It's a factor in that we use it to multiply, and conversion because we use it to convert from one unit to another. So for instance, let's say we have 70%, and we want to convert it to a regular number. So we multiply by 1 over 100%, which then reduces down to that, which further reduces to 7/10. So 70% equals 7/10. Likewise, if we have, let's say, 3.4, and we want to change that into a percent, we multiply by 100% over 1, which gives us 340%, moving the decimal point 2 places to the right to compensate for multiplying by 100. Anyway, my point is this and this convert. This converts from percents to non-percents. This converts from a non-percent to a percent. Unit conversion factors. The next 3 assignments are going to be about unit conversion factors. As you'll see over on the left side of the screen, we're going to deal today with American units. We have a whole bunch of information that's given. And the reason I wanted to go ahead and have this is the assignment you're going to be doing, and I'm going to do similar problems, but I wanted all of this information, abbreviations, length conversions, and instructions so that you can see what we're going to be using to do the problems. So we've got abbreviations for inches, feet, yards, miles. We've got the following equal or equations. 1 foot equals 12 inches. 1 yard is 3 feet. 1 yard is also 36 inches. Excuse me. 1 mile is also 5,280 feet. Skip the problem and go down to the instruction a little further. It says, any answer that is not a whole number can be written as a decimal only if it is a terminating decimal. If it is not a terminating decimal, then answers must be written as mixed numbers. So for instance, if we had, let's say 5/3, okay, that would be 1 2/3, which would be 1.6 repeating. So if we came up with this answer, we would instead use this. In other words, this particular assignment does not accept repeating decimals, okay? So let's go ahead and get started. And again, I'm going to use different numbers from the problems that are there, okay? So I'm going to call this my problem number 1, and I'm going to say, oops, okay. If I push down too hard, it messes things up. Convert 6.25 feet to inches. All right. So I need a roadmap. I want to go from feet to inches. Can I do that directly? Well, I look at the length conversions and I see that there's an equation that involves feet and inches. So the fact that 1 foot equals 12 inches means I could create the following unit conversion factors. 1 foot over 12 inches, which would be equal to 1, or 12 inches over 1 foot, which would also be equal to 1. So these are two different unit conversion factors based on this information. Now, when you're reducing a multiplication problem with a bunch of fractions and everything, if you have something on top and something on the bottom that are the same, you can reduce them out. The same thing is true with units. So I'm starting out with 6.25 feet, and that is over an implied 1. I want to multiply by the number 1, but keep in mind, both of these are equal to the number 1, but I want to get rid of the units of feet and introduce the units of inches. Now, if I use this one, things are not going to work out nicely because I've got feet times feet on top and inches on the bottom. So that would be the wrong unit conversion factor to use. Instead, since I'm trying to get rid of feet on top, I want to use the unit conversion factor that has feet on the bottom. 1 foot. Okay, so this unit conversion factor is equal to 1. I can take a number, a quantity, 6.25 feet, and multiply it by 1. So now what's going to happen is I'm going to go back and simplify. The units of feet and foot reduce out to just 1 over 1. And I have left 6.25 times 12 inches. I'm going to go ahead and use my calculator. 6.25 times 12 is 75, and the units are inches. So I've just converted 6.25 feet into 75 inches. Any questions about this particular problem, any part of the process? All right, then let's go ahead and look at another example. We'll take a look at another one, number 2, as I'll call it. Again, I'm not using the same numbers that they're using. Now I'm going to convert 78 inches. Let's see here. I should say convert to feet. Okay. So I'm starting out with 78 inches. Since I want to get rid of inches, I'm going to need inches in the denominator. I'm going to feet, so I'm going to need feet in the numerator. Well, looking at the information, 1 foot equals 12 inches right here. So 1 foot equals 12 inches. All right. So unlike last time where I had feet, oh, no, it's the same as last time. Let's see here. Oh, no, it's not. Okay, the first one was the wrong way of doing it. So where we've got, come on, mouse, there you are. Here, to go from feet to inches, we had inches on top and feet on the bottom. To go from inches to feet, we have feet on top, inches on the bottom, so that I can reduce out the units of inches. 78 times 1, I think I can do that without a calculator. Oh, wait a second. It's 78 times 1, but what's in the denominator? A 12. All right. So I've got what? 78 over 12 feet. Let's see if that comes out nicely on a calculator. 78 divided by 12 is 6.5 feet. So there's the answer. Let's say that instead of a decimal answer, I wanted to go ahead and get a mixed number answer. I would take 78 divided by 12, which goes in 6 times. And then I'd get what? 6 6/12 or 6 1/2 feet. So either of those answers would be correct. Again, any questions about the process? All right, let's take a look at another problem. We good to go on? Let's see. Let's convert 11 yards to feet. So I'm starting off with 11 yards. I want to go from yards to feet. Right here it says 1 yard equals 3 feet. So 1 yard equals 3 feet. Again, notice I put yards on the bottom to get rid of the yards on the top. So reducing out the common units, I now have 11 times 3, which is 33 feet. So 11 yards equals 33 feet. Now, usually about this time in a live classroom, somebody says, do we have to do all that? Can't we just take 11 times 3 and write 33 feet? Do we have to set all of this up like that? And the answer is yes, and here's why. If you're planning on taking any natural science classes, chemistry, biology, physics, astronomy, more than likely, you're going to run into a situation where you're converting units and they're going to expect you to use this method. So like it or not, it's not optional. You need to practice this. Okay. Moving on. Let's take a look at 4. Let's see. We're going to convert 27 feet into yards. So 27 feet. I'm going to want feet on the bottom and yards on top. Let's see. 1 yard equals 36 inches. Nope, that's not the one I want. 1 yard equals 3 feet. So 1 yard equals 3 feet. Okay. So units of feet reduce out. 27 over 3 reduces to 9 over 1. So my final answer, 9 yards. Also, I want to mention again, units. Notice, for instance, in this problem in WAMAP, they already have the units written out here. So in that case, you would just put the number in here, okay? But if there aren't any units written out, you may need to write them. So pay close attention to the units. Okay. Let's take a look at a problem like number 5. And we are going to convert 4 miles to feet. So I'm going to want what, miles on the bottom and feet on the top. And I see that 1 mile is 5,280 feet. 1 mile, 5,280 feet. The units of miles cross out. I'm going to go to my calculator and take 4 times 5,280, and I get 21,120 feet. So there's my answer. Alrighty. Again, any questions there? Let's see. Let's go down to problem number 10. Now, notice here we're talking about area conversion. So instead of 1 foot equals 12 inches, 1 square foot equals 120 or 144 square inches. Where are they getting that? Well, let's say we have a piece of tile that's 1 foot by 1 foot. So the area would be 1 square foot. But this distance right here is 12 inches, and this distance right there is 12 inches. So 12 inches times 12 inches would be 144 square inches. In other words, there would be 144 of these little square inches. So 1 square foot equals 144 square inches. Because we're talking 2 dimensions. Any questions about that? All right, so then let's go ahead and look at a problem like number 10. We're going to convert, let's see here, 8.5 square feet to square inches. So 8.5 square feet. So here I'm going to have square feet on the bottom, square inches on the top. Be careful, don't mix inches with square inches or feet with square feet. They're not the same. Well, 1 square foot is 144. Whoops, helps if you write the correct thing here. 144 square inches. Units of square feet on the top and the bottom, cross out. So now on our calculators, we're going to take 8.5 times 144, which is 1,224 square inches. And again, be sure to write square inches, not inches. Of course, here in WAMAP, it's already written there, but if there's a case where you have to write the units, make sure, is it square units? Is it just single units? Make sure you get that correct. All righty.
Are they always going to give us the reference, or is that something we should memorize, the conversions?
They are going to give you the reference, which again is one of the reasons I wanted to show what your assignment looks like. So you will have the information that's given there will be provided. You don't have to have it memorized.
Awesome, thanks.
That's where you make a big sigh and go, whew. Yeah. Okay. Let's take a look at number 14. And we're going to convert 4.25 square miles to acres. Okay. So I'm going to have square miles on the bottom, and let's see, acres on top. It says that 1 square mile equals 640 acres. So 1 square mile, 640 acres. Units of square miles cross out. So I'm going to take 4.25 times 640, which is 2,720 acres. All right, with that, let's see here. Here we go. Let's go down to problem number 21. Now we're dealing with capacity or volume, cups, fluid ounces, pints, quarts, gallons. That would also include teaspoons and tablespoons, but we're not going to use those today. All right, so we're going to convert 6 1/4 cups to fluid ounces. Now, I want to go off on a little side note for a minute here. Let's go back here and we'll just use this. There are 8 fluid ounces in 1 cup. There are 16 ounces in 1 pound. These and these are not the same, okay? A fluid ounce is a volume. So it's not how much it weighs, it's how much volume it takes up. An ounce is a weight. So 16 ounces equals a pound. 16 fluid ounces does not equal a pound, okay? Unless I suppose you happen to have a fluid ounce that weighs an ounce, but they're different kinds of units. So be careful again in labeling if you're required to label that you don't get those two mixed up. Okay. All right. Convert 6.5 cups to fluid ounces. Well, let's see here. It says that 1 cup is 8 fluid ounces. So 6 1/4 cups. And then we're going to have 1 cup, 8 fluid ounces. Cups are going to cross out. But I have a problem here, okay? Because I can't really do a mixed number times a whole number easily. So I'm going to need to change my 6 1/4 either into a improper fraction or into a non-repeating decimal. As long as it's not, as long as it's just a terminating decimal, we could go either way. Shall we change it to a decimal or to an improper fraction? Anybody preferences?
Improper.
Okay. So 6 1/4 would be what, 25/4? So basically what I would do is at the very beginning, I would change that. Notice that the 4 went downstairs in the denominator. I made that fraction bar a little bit too long there. So now I've got 1 cup and 8 fluid ounces. Okay. Units of cups reduce out. No, 8/4 is 2/1. So I've got 25 times 2 is 50 fluid ounces. But again, I had to take the mixed number and change it into an improper fraction or a decimal. Does anybody want me to do the problem using the decimal? Okay, then we won't. All right, let's take a look at, let's see here. Let's do 22. Or get one like it. I want to convert 31 fluid ounces to cups. So I'm going to start out with 31 fluid ounces over 1. So I'm going to have fluid ounces on the bottom and cups on the top. 1 cup is 8 fluid ounces. The common units of fluid ounces cross out. So I've got 31/8 cups. Let's see on the calculator. If I do 31 divided by 8, I get 3.875 cups. That is a terminating decimal. So that would be an acceptable answer. Or you could do a mixed number. 31 divided by 8 goes in 3 times. And a remainder of 7. So we'd have 3 7/8 cups. So we can have either one of those as a correct answer. Any questions there? Okay, let's go down to problem number 40. Okay. We're going to convert 464 fluid ounces to gallons. Now, there's a problem. I don't have information here that tells me exactly how many fluid ounces are in a gallon. So unless you happen to know that off the top of your head, we're going to have to do several unit conversion factors. So this is, I kind of hinted at this at the beginning, and then I didn't do anything about it when I talked about a roadmap. Okay, I want to go from fluid ounces to gallons. How can I get there? Well, I can go from fluid ounces to cups, then from cups to pints, then from pints to quarts, and then from quarts to gallons. So I'm going to go fluid ounces to cups, cups to pints, pints to quarts, and quarts to gallons. So there's my roadmap. Okay. So here's how we're going to set this whole thing up. We're going to start with 464 fluid ounces over 1. We're going to have 8 fluid ounces is 1 cup. Fluid ounces on the bottom to cross out fluid ounces on the top. But I don't want cups, I want gallons. So I'm going to have cups here and pints there. 2 cups is 1 pint. So the units of cups cross out. But I don't want pints, I want gallons. So now I'm going to go from pints to quarts. 2 pints is 1 quart. Pints go away and I've got quarts, but I don't want quarts, I want gallons. And let's see, 4 quarts is 1 gallon and the quarts go away. You'll know you're setting this up correctly if the units reduce out, okay? If you end up with cups squared or something, cups times cups on top or something, then you've got it upside down. So you've got to set them up so that you get rid of the previous one that's in the numerator by putting it in the denominator in the next factor, unit conversion factor. Okay. So now my units are gallons. And I can go back and I suppose I could do this all at once, and we'll see what happens. I've got 464 over, let's see, 8 times 2 is 16, times 2 is 32, right? And 32 times 4 is 128. So I've got 464 over 128 gallons. Let's see what happens. 464 divided by 128, 3.625. Okay. And I could also do that as a mixed number by using long division. I'm not going to bother at this point, unless some of you want me to. Anybody want me to do the, no, nobody cares. Okay, fine. All right. Any questions about that? So there's a lot going on there, and I highly recommend that you go through this, lay out how you're going to get there. Have any of you ever taken a road trip and you just get in the car and go? You don't have any plans, just like go wherever? Well, that might work out well, and you might end up sleeping in your car, depending on, if you didn't plan well. So I highly recommend this, so you know where you're going and how you're going to get there. Because otherwise, people sometimes they kind of wander around in circles and aren't sure what units to use. So lay it out ahead of time, especially when you have a lot of them like this. Okay, let's see here. 53 I had. So now we're dealing with units of time. And we're going to say convert 7 1/2 hours to seconds. All right. Well, I don't have any information up here that tells me directly hours to seconds. I've got hours to minutes and minutes to seconds. So there's my roadmap. Hours to minutes and minutes to seconds. Okay. Also, I don't want to use 7 1/2 I either want to change that to an improper fraction or a decimal. What shall we use? Improper fraction or decimal? I can't hear you. What are you mouthing?
Decimal, sorry.
Decimal? Okay. So 7.5 would be what? 7.5. Is everybody okay with how I got there? All right. So 7.5 hours over 1. Hours to minutes. Minutes to seconds. So I've got my units lined up. 1 hour is 60 minutes. 1 minute is 60 seconds. Again, notice how I laid out the units first, because if the units aren't going to work, the numbers aren't going to matter. It's going to be wrong. So get those units correct. Hours is going to reduce out. Minutes are going to reduce out. So I'm going to take 7.5 times 60 times 60, and I get 27,000 seconds. So if you have a job and you're working 7.5 hours a day, if you sit there and count the seconds, you're going to get all the way to 27,000, but then you're probably going to get fired if all you do is sit there and count the seconds, right? But so don't do that. But all right, we okay with this? So what we've been doing, we've been converting a certain unit into another certain unit. So converting one unit to another unit. Now we're going to look at converting a rate to another rate. And recall that a rate has two different units. Okay, we're going to take a look at a problem like 55. Okay. And we're going to convert 150 miles per hour to feet per second. All right, so we've got 150 miles per 1 hour. Now, in the previous problems, it was some unit over just the number 1, but now it's over 1 hour because this is in fact a unit rate. So we're going to convert from the unit rate of miles per hour to the unit rate of feet per second. All right, so I'm still going to form a roadmap. On top, I can go from miles to feet. I've got that information right there. On the bottom, I'm going to go from hours to minutes to seconds. Okay? Because I can't go straight from hours to seconds. I don't have that piece of information directly available. Okay? I think I didn't leave myself quite enough room. So I'm going to rewrite that. Okay, so I've got 150 miles per hour. Okay, so I need to convert miles into feet and hours into minutes and minutes into seconds. I recommend that we just deal with one thing at a time. I'm going to start with the numerator. So I'm going to work on changing miles into feet. So I would do that the same way as before. 1 mile is 5,280 feet. Crossing out the units of miles, I now have feet on top. That's what I want, but I have feet per hour. All right, now, up until now, we've been dealing with a single unit that was in the numerator. And so to get rid of it, we put the unit conversion factor such that that same unit was in the denominator so that they would cross reduce. Now we have a unit in the denominator of hours. So to get rid of that, I need to put it on the other side of the fraction bar. To get rid of one on top, you need it on the bottom. To get rid of one on the bottom, you need it on top. Okay, so you see what I did there? So now hours goes away. Well, now I've got feet per minute. I'm almost there. I need to get rid of minutes and get to seconds. 1 minute is 60 seconds. Minutes cross out, and now I have feet per second. So again, if you're trying to get rid of something in the numerator, your unit conversion factor has to have that unit in the denominator. Trying to get rid of something in the denominator, it's got to be in the numerator of the unit conversion factor so that they cross out. Okay, so I've got the units I want. So now let's do the math. I'm going to do some quick reducing just because it's easy to do. I'm going to divide the top and the bottom by 10. Do you see how I did that? I'm going to divide the top and the bottom by 10. Well, let's see here. What have I got on top? And I could have left it. It was easy to get rid of. So I did 15 times 5,280 is 79,200 over 6 times 6 is 36. And that's going to be feet per second. But it needs to be so many feet per 1 second, right? So I need to divide 79,200 by 36. So 79,200 divided by 36. And I get 2,200 feet per second.
Isn't it 15 times 528, or is it still 5,000?
Okay, did I use 5,280? Are you talking
Yeah.
about- is that what I did? What that means is I need to put my glasses on. 15 times 528. Yes, thank you. Should have put my glasses on. All right, so let's go back. And let's do that correctly. See, even with a calculator, I still make mistakes. In fact, I typically make more mistakes using a calculator. What does that mean? I don't know. Okay. So this should be 7920 divided by 36. And this is feet per second. Thank you. So that divided by 36, we get 220 feet per second. That's a wee bit slower than what I had before, isn't it? Yeah, sorry about that. I'll leave my glasses on. All right, we okay with that? Yeah, I went to all the trouble to cross out the 0 and then I used it anyway. What's that all about? Any questions there? Okay, we're going to look at another one. See if I can redeem myself on this one. I'll try. So now we're going to go the other way. Instead of going from miles per hour to feet per second, we're going to go from feet per second to miles per hour. So I've got 66 feet per second to miles per hour. Okay, roadmap. So I'm starting out with feet per second. I'm going to go from feet to miles and seconds to minutes to hours. Okay. So basically, I'm going to use all the same unit conversion factors I used before, but they'll be upside down because I'm going the other direction. Okay. So that'll get us from feet to miles, and that's what I want on top. "60 seconds is 1 minute. That'll get us miles per minute, but I want miles per hour. So now I've got miles per hour. Okay. I'm not going to get rid of any zeros since that's where I screwed up before. I'm just going to live with them. So in the numerator, I've got 66 times what? 1 times 60 times 60, which is 237,600, and that's miles per what? 5,280 hours. So now I'm going to take 237,600 divided by 5,280, and I get 45 miles per hour. Exactly. I got that one right, didn't I? So I'm back in good standing, because I know how it is. I screw up and then you don't believe anything I do after that. I just have to go back to bed. If it was Monday, I would, but since it's Friday, no, I'll maybe stay up a couple of hours. All right, are we okay with this? So, common mistakes that people make, they don't pay careful attention to how they write their unit conversion factors. They get them upside down and then they can't figure out why they're getting the wrong answers. You can't cross, if you've got like miles and seconds, and over here you've got miles, feet, or no, let's say miles, hours or whatever. You can't cross out the miles if they're on the same line, okay? You gotta have one on top, one on the bottom, or one on the bottom, one on top, all right? Now, I know this is a long assignment, but this'll keep you safe and off the streets this weekend. But here's the good thing. The practice you're going to be using is going to make the next 2 assignments way easier. Today we're dealing with American units. On Monday we'll deal with metric units. Everybody loves metric units, right? Yeah. And then Tuesday is the free-for-all, where we convert back and forth between the two. That's how fun it is when you go up to Canada and try to figure out how fast am I going and how much is this costing and all that. But anyway, have a great weekend. I will be back this afternoon at 1:15 for any of you that have questions. Otherwise, take care, and I'll see you on Monday. And I'm going to stop the recording as soon as I find my mouse.